crust is broken into separate pieces called tectonic plates. It's composed of two distinctly different types of material, the less dense continental crust and the more dense oceanic crust. Both types of crust are solid in the upper mantle. The upper mantle in turn floats on a denser layer of the lower mantle that is much like thick molten tar. Each tectonic plate is free-floating and can move independently. Geologists have hypothesized that the movement of tectonic plates is in relation to convection currents. Convection currents are where Earth's hot mantle rises to the surface while the cooler liquid sinks. As it sinks, it heats up and rises again. This process is called convection currents. As these currents rise in the mantle, the Earth's tectonic plates are forced to move either way, each one towards each other or past each other.
A divergent plate movement is when the crust is being forced apart. This is known as a divergent or constructive plate boundary. New crust is forming from magma that rises to the Earth's surface between the two plates. An example of the divergent plate boundary is the Mid-Atlantic Ridge. It is in the middle of the Atlantic. A vast underwater mountain range rises from the ocean floor and extends almost the entire length of the ocean. This submarine mid-Atlantic ridge owes its form to the movement of the continental plates on either side of the ocean. As these plates slowly separate, they leave gaps in the Earth's crust. This allows molten rock from beneath the Earth's crust to reach the surface, forming a new part of the ocean floor. As the molten rock seeps through the gap at some pressure, it spews upward, forming a ridge. The Mid-Atlantic Ridge is so tall that it actually rises above sea level in many places, forming volcanic islands. Divergent plate boundaries can create features such as a rift on land, which is a linear zone where the lithosphere is being pulled apart. It also can create hazards, such as earthquakes and volcanoes. When oceanic crust converges with continental crust, the denser oceanic plate plunges beneath the continental plate. This process, called subduction, occurs at the oceanic trenches. The entire region is known as a subduction zone. The subduction zone have a lot of intense earthquakes and volcanic eruptions. The subducting plate causes melting in the mantle above the plate. The magma rises and erupts, creating volcanoes. An example of the oceanic continental convergence is the Andes mountain range. The Andes mountain range was formed from the result of the Nazca plate being subducted under the western edge of the South American plate. A subduction zone occurs when a heavier and denser tectonic plate goes under a lighter, less denser plate. In the case of the Andes, the Nazca plate was lighter than the South American plate, which subducted under the Nazca plate, creating this giant mountain range. This process did not happen overnight, as researchers claim that uplift started over 25 million years ago, with the process still continuing to the present day. Oceanic continental convergence can cause hazards such as earthquakes and volcanoes on land, as well as features like underwater trenches. Trenches are steep depressions in the deepest parts of the ocean where old ocean crust from one tectonic plate is pushed beneath another plate, raising mountains. They can also make mountain chains. Mountain chains are a row of high mountain summits, a series of interconnected or similar mountains, or mountains touching each other in a larger mountain range. Shield volcanoes are formed by lava flows of low viscosity. Lava of low viscosity is lava that flows easily as it is running. This causes a volcanic mountain building up over time. Shield volcanoes can be found at divergent plate boundaries and hotspots. Many of the largest volcanoes on Earth are shield volcanoes, such as the Mauna Loa volcano in Hawaii and the Kilimanjaro volcano in Tanzania. A hotspot is in the mantle where heat rises from deep in the Earth. It is formed by magma rising through cracks and eruptions to form volcanoes. Hotspots are linked to shield volcanoes, as some shield volcanoes are created at hotspots such as the Mauna Loa volcano in Hawaii. When a shield volcano erupts, it causes lava flows to go down the side of the volcano in both flowing form and in solidified form. The Mauna Loa is an example of a shield volcano. It is found in Hawaii and is the biggest shield volcano in both mass and volume. The last time the Mauna Loa erupted was in 1984 on the 15th of April. The Mauna Loa volcano is an example of Hawaiian eruption. A Hawaiian eruption is where lava flows through from the vent with low level of eruption and low viscosity. Also, the Hawaiian eruptions produce very little volcanic ash. The Mauna Loa had both positive and negative impacts. The positive impacts of the eruption was that the lava and ash deposits created fertile soil, increasing agriculture and jobs. It also generated heat, creating the potential to provide geothermal energy. The negative impacts of the eruption was that people were killed and injured, causing a rise in the death toll. Also, the ash released by the volcano caused a negative impact on the world's climate. Due to the ash released by the volcano, airport travel was affected, causing delays in flights and cancellations. Also, the eruption caused the destruction of habitats, causing environments to be affected and animals to survive without their natural habitats. The eruption in Hawaii also caused a major destruction to their crops that were growing and also contaminated their drinking water. Over time, composite volcanoes are formed by the collision of oceanic and continental plates and also oceanic and oceanic plates. This is called oceanic continental convergence or oceanic-oceanic convergence. When the oceanic plate subducts beneath the oceanic plate or the oceanic plate subducts beneath the continental plate, the oceanic crust melts because of the extreme heat. This then forms very viscous magma, which rises and solidifies as the gas trapped in the magma is released. This then adds to the slope of the volcano. Also, ash is built up to create the slope of the composite volcano, making the slope of the volcano built up of layers of both magma and ash. Composite volcanoes can cause the following: pyroclastic flows, lahars, and tephra-falls. Pyroclastic flows is a current of fast-moving hot gas and volcanic matter which can travel at high speeds of up to 700 km per hour away from the volcano. Lahars is a destructive mudslide that occurs on the side of a volcano. Tephra-falls are when fragments of rock are forced out of an erupting volcano. An example of a composite volcano is the Mount St. Helens eruption in 1980 on the 27th of March. The eruption destroyed over 200 homes and many roads and railways were damaged. Mount St. Helens was formed by the Juan de Fuca plate subducting beneath the North American plate, which formed Mount St. Helens and many more volcanoes along the plate boundary. The Mount St. Helens volcano is an example of a Pallinian eruption. A Pallinian eruption is a very destructive eruption which obliterated the entire top of Mount St. Helens. When the eruptions are massive, the magma chamber can be emptied by the eruption, causing no volcanic activity for a certain period of time. The Mount St. Helens eruption had negative impacts but no positive impacts. One negative impact was that it caused over $3 million in today's US dollars of damage. This caused money needing to be moved from certain areas by the government into other areas to fund the damages. Another negative impact of the eruption was that it caused significant loss of life in a matter of a few hours after the eruption had begun. Overall, 57 people died. They lost their lives from the lahars and the ash fall.